Hi, everybody. This is Tom Salemi of DeviceTalks. Welcome to the AbbottTalks podcast. Over the past few years, the world has come to recognize Abbott as a company dedicated to helping people live happier and healthier lives. In this podcast series, we'll talk with the healthcare leaders, the executives, and the engineers who are working every day to develop new technologies to help people live their best lives. I know you'll enjoy this episode of the AbbottTalks podcast. Hey everyone, this is Tom Salemi. Welcome back to the AbbottTalks podcast. I'm thrilled to be here with our co-host, Kayleen Brown, the amazing managing editor of DeviceTalks. Kayleen, great to be on the show with you again.
Well, thank you for having me, and I love all of the amazings. Keep that coming.
Oh my gosh, there's not enough amazings in the dictionary. I guess there's only one amazing in the dictionary, but you are capital A amazing, and I'm also thrilled that we have an amazing topic to talk about today. Kayleen, I love neuromodulation. I think it's one of the cooler medtech spaces. Do you agree?
I completely agree. It's actually one of the reasons that I was so intrigued with medical technology. Was just the idea that you can support and you can treat conditions that we understand, conditions that we can put our finger on, but talking about pain as one example, that is a really real thing. And, how do you treat pain? And pain has so many issues around it. So the idea how neuromodulation can help support that is really encouraging outside of in addition to all of the amazing benefits of neuromodulation. So I'm really interested in better understanding what it is and how we can use neuromodulation to help support other conditions and treat patients.
Absolutely. There's certainly a magical quality about it. I think my first neuromodulation memory was when I first read about NeuroPace back in the late 90s. And I remember reading that saying, oh my God, like you can stop an epileptic seizure with a bit of energy. It was pretty amazing revelations. So I'm thrilled to dig deeper into the neuromodulation story, Kayleen. We have a great expert to help us do that. We'll have as our guest today, Yagna Pathak. She's the medical science manager of Abbott's neuromodulation business. Yagna, thank you for joining us on AbbottTalks.
Thank you so much for having me here today.
So Yagna, we have a lot of questions. One, I think that we already kind of prefaced that we really want to better understand neuromodulation and, of course, Abbott's relationship to neuromodulation. But before we do that, we always like to ask, how did you find your way into medical technology, the best industry in the world?
Yeah, so, I've been with Abbott for about 7 years. I started here in 2018, but my relationship with neuromodulation has been a little bit longer. I studied it as part of my graduate career, so I've been in the field for about 15 years. But really, if you're asking about, the motivation or the inspiration for going into medical technology as a whole, I will say that when I was younger, I was really fascinated by space, but also the brain. And then I really loved learning about the vastness of the universe. And eventually I realized that the complexity of the nervous system really does mimic a lot of the intricacies that we see around in the universe. And so that really inspired my love for, just curiosity in general, but also my kind of passion into how can we actually use technology to treat, diseases of the brain and the nervous system. And so I ended up pursuing biomedical engineering, and here I am.
Were you looking at aerospace initially, or?
I was actually, yeah. So I was looking at aerospace engineering, and I had very much made up my mind to be a double major, aerospace engineering and math, because I loved numbers that much. And but there was a part of me that also was really interested in medicine, and so I really got influenced by my mom, who found out about this very integrative program, which was fairly new at the time that I was entering college. And she was like, hey, you love medicine, you love technology, why don't you try this thing called biomedical engineering? And one of my first exposures there was to a myoprosthetic limb, and that's how I got hooked.
Wow. My son is studying mechanical engineering, wants to go into aerospace. I've had that conversation with him a few times, and your mom was better at it than I am, apparently, because he's still going to aerospace. And Someday we'll lure them into medtech. But
One
that's a
of
great story.
us.
One of us, exactly.
This space is still pretty cool, but I love our field for sure.
Absolutely.
Do you feel as though, well, there's kind of two thoughts that came in mind. So I'm a Instagram lurker. So I look at posts, but I don't do anything with them or post myself. And I follow a space site or a space profile. And what always strikes me is they take imagery of, let's say, the pupil, like our human pupil, and then they'll match it to space. And the like symmetry and the geography and the design of the shapes and the mathematics behind it, they're all so similar that it really is one of those moments that's like we are all part of such a bigger picture of a, I mean, what is it? We're all space dust.
Yeah.
And I love that. Like, I love that. That feels very humanizing in some ways. Like we're all made out of the same stuff. So let's treat each other well, treat our conditions so we live longer and can have more space dust. So you talked about sort of neuromodulation as having a relationship with that kind of from the beginning. From your graduate program or your PhD program to Abbott, was that the next step, or did you have other steps in between that?
Yeah, so I took a couple steps, retrospectively, it always looks very linear. But I actually, when I joined my PhD, I was very much interested in neurotechnology, but didn't really know much about neuromodulation. But the lab that I ended up joining, they were focused on neuromodulation, specifically for neuromodulation for psychiatric indications. And that's really how I got introduced to the field. And then the more I learned about how we can use engineering technologies like computational modeling and imaging, it really kind of helped me kind of grow within that field. So that was really the focus of my PhD that I did at Marquette University, really focused on computational modeling and imaging to understand how neuromodulation intervenes for depression. And then moving on from that, I really, and I did my PhD in a very engineering, focused training, but I really kind of was craving for more of a clinical experience as well. So I ended up doing a postdoctoral fellowship at Columbia University in the Department of Neurosurgery. And over there, I actually did get to be in the OR a little bit more.
Wow.
Interface, see firsthand that interface between technology and humans, and was an incredibly rewarding experience. And I do want to take a second to just give a shout out to both my PhD and my postdoc advisors, Chris Butson and Samir Sheth, who really trained me in this field, and I think gave me a very interdisciplinary lens at this technology in terms of what is the potential of technology, but also what is the impact that we can really have on people who are going through these neurodegenerative chronic conditions. So I think that holistic perspective then, kind of just left one more itch, which was to kind of see it, be scalable and to really see how all of these thoughts and ideas can really translate into innovation at a much broader scale. And that's kind of what brought me to Abbott. And so I joined in R&D and did some great work, worked on some really high impact solutions within brain therapies as well as chronic pain. And then about 2 years ago, I joined my current role, which is within medical affairs.
That's fantastic, and I love that you pointed out that it looks like a linear path, because if you look at your LinkedIn profile, I was looking at it prior to the interview, and I was like, this person was like focused, like laser focused on this path, and it's fascinating to have you say, there was some doubt here and there and some discovery. I think it's important for people to hear that. I think everyone thinks everyone else has it all figured out, and we don't. I think we're all sort of packing as we go or unpacking as we go. Let's get into a bit into the overview of neuromodulation. As we talked about the start. We both find the area fascinating. I've been enamored with it since the early NeuroPace days, and I saw you shaking your head when I recounted the NeuroPace story. Give us a bit of an overview of the neuromodulation space, maybe just not too deep, but a little bit of its history, of its impact, and maybe a sense of where we are today.
Yeah, absolutely. I think when we think about neuromodulation, right, it is such a fascinating and cool technology that it's hard to kind of accept that it's part of our daily life today. But really, neuromodulation, if you kind of go back into history, it really began like, in the Roman times when they were initially using electrical fish to treat headaches. So that's really as far back as we can
Whoa.
kind of trace the human history of, kind of experimenting with electrical stimulation and how it can have an impact on neurological conditions. I would say in the more modern times and the way that we really get to practice neuromodulation today, for the chronic pain therapies, the pivotal point was really in the 1960s when we got a better understanding of the gate control theory, which really helped us understand how we process pain better. And that really opened the doors to spinal cord stimulation, which is a widely accepted therapy and effective for chronic pain conditions. And then for movement disorders, the neuromodulation therapy that is typically used is deep brain stimulation. And so deep brain stimulation really kind of rose, to popularity in the 1980s. There were a lot of seminal studies done in the late 80s, and it really got approved for neuromodulation for movement disorders in the late 90s and early 2000s, specifically for Parkinson's disease and essential tremor. And when I think about this history, it really kind of helps me understand how, technologies really make their way into therapies. And I think part of it is a better understanding of the mechanisms of action of the things that we're trying to treat. And then part of it is just being able to, have a measurable impact. And you kind of see that on the both sides of chronic pain conditions where it was really a scientific understanding that kind of opened the door there. And on the movement disorder side, there was already a history of kind of understanding how lesion techniques can improve some of these conditions. And the ability to kind of instantly see the improvement in behavior was really the catalyst here in bringing this kind of technology to a therapeutic space.
So you've identified a few of the principal areas that are treatable with neuromodulation. What are there some that we're not really aware of yet? So I guess what I'm wondering is, are we really just limited to the areas that you've identified, or do you see a lot of green space or blue space or white space or whatever color space you want to make it, where neuromodulation could be applied and could provide treatment?
Yeah, I think that's a great question, Tom. I will say that we're currently indicated for these two conditions that I mentioned, these two spaces that I mentioned, right? So chronic pain conditions for spinal cord therapies, and then movement disorders, including Parkinson's disease and essential tremor for deep brain stimulation. But I think you've kind of hit the nail, right? When we think about neuromodulation, at its core, it's really applying electrical pulses to the nervous system to modulate something that has gone awry. That's really the definition of neuromodulation, right? The two therapies that we talked about are implantable therapies, and they're very specific, and they're very, they kind of intervene at a very specific level. As we think about other indications out there, there is a lot of investigational work that's going on. Abbott actually kicked off a study last year called the Transcend study, which is really investigating the use of deep brain stimulation for treatment-resistant depression. And so as we think about the overall impact that these technologies can make, there are wider applications. Most of them are still investigational, but I think the future is really bright here.
We're going to take a really quick break from our conversation with Dr. Yagna Pathak, Medical Science Manager, Medical Affairs at Abbott's Neuromodulation business, to bring in our episode sponsor, Surtech Medical. Enjoy. Brad Womble, Senior Director of Strategy for Surtech Medical. Welcome to the podcast.
Nice to meet you, Kayleen. Thank you for the invitation. Glad to be here.
Oh, really? It's going to be my pleasure. I promise you this, Brad.
Okay.
So for our audience, I always like to start at the 40,000 foot level. So for those who don't know who Surtech Medical is, could you give us a brief overview? Who's Surtech Medical?
Yeah, Surtech, we are a diversified medical device company. We primarily focus on both Class 2 as well as Class 3, which are implantable medical devices. And we're really focused on a couple of key areas. We're really focused in the neurology space in a place called neuromodulation, which is all about how to stimulate nerves, read nerves, that sort of thing. And then we're also really focused on the interventional therapy space, and that could be either neurovascular type products as well as cardiovascular products, but all of them are more interventional. So they're going in your body, but then they're coming back out. But all of them generally are in sort of the higher order of magnitude in terms of advancement. So electrophysiology, structural heart, things of that nature are what we're kind of focused on at Surtech.
Well, it's really helpful to understand kind of the breadth and depth of your coverage. I know that I'd like to learn a bit more about your capabilities, but you caught my interest, Brad, when you said neuromodulation. So I just had the pleasure of co-hosting this episode of AbbottTalks where we talked through neuromodulation. And as a layperson in this space, I got a better understanding of, really what that is. Could you walk us through how Surtech Medical works within neuromodulation?
Yeah. So the beautiful thing about our business model is that we're really supporting the entire continuum of the industry. So we're really excited to work with the people that are focused on the clinical trials, the ones that are actually doing the research with either benchtops or with animals or with humans to figure out exactly how we can support and build a better device. But we're also working with the small and medium-sized and large-sized companies along that continuum as well. So depending upon what their needs are, depending upon what therapeutic areas, we can adjust the platform that we have in order to suit those different purposes. So we both have our own platform that can support all different types of neuromodulation applications to help give them a leg start. We would use the platform if the customer, whether it's the clinician or the company, wants to try to get to market, sooner, faster, perhaps 2 to 3 years sooner. We could use our platform to support them. However, if they have a very custom type application, that's something that we can support them with as well. We could build that custom application for them. That journey might be a little bit longer, though. I mean, typically it takes 5 to 7 years to get a product from start to development within the neuromodulation space. So unfortunately, it can take a little while. But if you can get a head start, use a platform that like what we have that's already been on the market for a while, that could save 2 to 3 years of effort and can be used for many different types of indications. So we work across the spectrum from clinicians to large companies, and then the services we offer, we're able to customize depending upon where their needs are at as well. But there's a lot of diversity within the neuromodulation space right now. It's a real exciting time.
Can you help me understand your neuromodulation platform, Excel Plus, and how that benefits the industry?
Yeah. The beautiful thing about Excel Plus, Surtech Medical, by our nature, we're a contract manufacturer, meaning we love working with companies to help manufacture their devices and to help think of ways of taking their devices to even the next level. But one of the areas when we started our business is we're realizing that we have a lot of customers in the neuromodulation space that don't have their own platform. They have to develop their own platform, but they already have the therapy idea immediately. They already know how they want to use that device. But if it takes them 7 years to go from initial conception all the way to production, that's 7 years that therapy is not going to be in the market, and it's not going to be benefiting the patients that absolutely need it. So our thought process was, well, why don't we acquire a platform that's already been a medical device, that already has gone through the FDA approval process, and take that platform and open it up, open source that to our customers so they can use that platform. And what we're finding is that in a lot of cases, it's 2 to 3 years of development time that are taken off the table. So, we're taking development times from, say, 5 to 7 years to, 3 to 4 years, and in some cases a little bit less if we're able to show proven applications. But the beautiful thing about our platform is it could be used for deep brain stimulation, spinal cord stimulation, which are about 80% of the market today, but also can be used for vagus nerve stimulation in your neck and other types of peripheral nerve stimulation as well.
Thinking about in the next 2 to 3 years, what are some examples, or even in you're seeing now, what are some examples of neuromodulation products or even research that you've seen and that you're excited about?
Yeah, well, a couple of the areas that we're touching are pretty exciting. There's a couple of areas that we're not touching that I'd love to touch. But what we're seeing is that we're seeing miniaturization within the neuromodulation space. So a lot of our platform and other platforms, there's basically kind of like an IPG can. It's actually, I've got one here. It's they're about this size. This is our Excel Plus platform. Or
So it fits in the palm of your hand.
It does. And there's leads that come out from it that either are implanted in the spine or in the brain. But what's exciting is that they're starting to be able to miniaturize these devices. And imagine having a complete IPG, a complete one of those things that I just showed you, but implanted in your body right next to your nerve. And imagine having a bunch of those little tiny sort of neurostimulators implanted all over the nerve that you're trying to target. One, it miniaturizes it. It reduces the footprint. And the idea is that you're able to place those exactly where you need. So miniaturization of that technology is going to be super exciting. We're already starting to see that for deep brain. Imagine tiny little little rice little tiny rice samples that are kind of embedded in your brain in the right spot instead of actual leads and wires that are kind of going down. But I'll tell you where it's going, and this is what's really exciting. Nanobiology. Imagine that you're able to create little tiny nanobots that can resonate at a certain frequency. And imagine adding a little bit of iron, a little bit of ferritin, something that could attract a magnet. And let's say that I had like a shoulder injury. Now imagine that your body safely had these nanobots kind of floating around in your body that could resonate at a specific frequency. And you attracted them using, say, like a little mat or something that's covering your arm. You could theoretically, have your complete shoulder resonating at a certain frequency with these nanobots that could theoretically heal that part of your body in, some sort of exponential way. Now, we're a ways off, from that, because obviously we have to get through the bioethics of that and so forth. But I mean, that's the future. The future will be using nanotechnology to help, heal our bodies, and that will be the neuromodulation of the future, I believe.
It's the future, but it goes right back to what you were just saying about the past and the architecture and the vibrations. It's sort of like it's
everything's
parallel.
About frequency. Everything's about frequency, it's really exciting. On many different levels, it's exciting.
We're Brad Womble, Senior Director of Strategy at Surtech Medical. This has been one of the highlights of my week. Thank you so much for joining me on the podcast. I loved learning more.
My pleasure. And thank you for the invitation again.
And that concludes my conversation with Brad Womble, Senior Director of Strategy for Surtech Medical. I know I learned a lot, and I hope that you did too. And I wanted to say a big thank you to Surtech Medical for sponsoring this episode of AbbottTalks. Without your support, we don't have the opportunity to tell these incredible and important medtech stories. So thank you, thank you, thank you. And for our audience, if you want to learn more about Surtech Medical and how they can help you engineer a new future for medical devices, please visit their website at surtechmed.com. That's CIRTECMED.com. And now we bring you the conclusion of our conversation with Dr. Yagna Pathak of Abbott's neuromodulation business.
Can you help us understand, for a layperson, the neuromodulation's impact on the body itself? So you can choose, however you want to go behind that. Because I understand it, I think, at the top level, but kind of the application, like what are we expecting? Like, what's the impact on the body?
So, the fun thing about the nervous system that I really find fascinating is that it kind of, it's an input. I'm an engineer at my core, so I'm going to go into some engineering analogies here, right?
Please.
The nervous system really is an input-output system, right? It takes signals from the outside world, and your peripheral nervous system really transmits them to the central nervous system, which is the spinal cord and the brain. And then the brain and the spinal cord really process this information, and then they tell the body how to react to these external signals, to these external stimuli, right? That's really the role of the nervous system in our life. And thankfully, it's a very important role and one that is very critical to like everyday living, right? And quality of life. When I think about like the impact to the body, I would say that, anything, and at any level, when we interface with the nervous system, we are impacting the body because we're either impacting signals that are being received or we're impacting signals that are actually being transmitted. And so for something like pain, right, where we have spinal cord stimulation, it's a little bit of, kind of understanding, okay, these are abnormal signals that are bringing in the information about pain, and it's not appropriate to have this reach the central nervous system or have this reach the brain, and then they get interrupted kind of midway, right? So that's one of the ways that those signals get interrupted, and that's, I would say that the impact on the body is that it doesn't feel the pain because those signals got interrupted, right? Similarly, when we think about movement disorders, it's a very behavioral, condition, right? You see tremor in patients that have Parkinson's or essential tremor. You might see shuffling, you might see abnormal gait, rigidity, etc. also with these conditions. And intervening at the nervous system level, so at the brain level specifically for these disorders of the movement disorders with deep brain stimulation, when you're interrupting those signals at that level, the downstream impact really is that you're correcting for these abnormal behaviors, these hyperactive behaviors like tremors. So that's when you kind of think about this like input-output system, which I hope that analogy made sense, but that's how I think about it as an engineer. You're really impacting both how that information is processed by the nervous system, but also how that processed information then turns into some instructions back for the body, which then helps you kind of correct for these conditions.
That makes me think about data and like input of data and output of data and how you can interrupt the input or interrupt the output. So that I think that analogy makes perfect sense. Thinking of data also brought me to sort of connectivity. So we know that one of the advantages or advancements for no treatment is connectivity. How does that help patients?
Yeah, so when we're talking about connected care, we're talking about technologies like our Neurosphere Digital platform, which was a pioneering technology in terms of connecting patients and physicians, through remote technology. And so, we worked on this technology starting in 2019, and it was released, in 2021 when it was really important, as we were at the peak of the pandemic at that time. And when I think about the connectivity of this kind of technology, it's really based on kind of the patient experience, right? We're dealing with disorders that are incredibly burdensome, incredibly debilitating, and whatever we can do to kind of make the experience a little bit better for these patients and to make sure that they're receiving care in a timely fashion. Those are the two most important things. Beyond clinical benefit, which we know we can get with these neuromodulation therapies, the two biggest things that we can try to fix here is, making this less burdensome for the patient and making sure that they have access to care exactly when they need access to care. So with the kind of connected care technologies that we have, the Neurosphere Virtual Clinic platform, as well as the new Neurosphere Digital Health app that we just released about 6 weeks ago, I think. Wow. With both of those kind of technologies, the goal really is to make sure that patients can connect with their physicians, patients have access to information exactly when they need it, and they get care in a timely manner. And overall, you're just trying to improve their experience a little bit more. We actually had a study that just came out earlier this year called the Rome study that did show that access to these kind of technologies actually does help patients get to improvement of symptoms much faster, which kind of speaks to the impact that these technologies are really having in kind of accelerating the pace of therapeutic response and overall helping these patients stabilize a lot sooner.
Yagna, I just wanted to I think that's a great point about the power that connectivity gives to medical devices, because we can talk about the therapeutic benefits, but if they're not applied, and if patients aren't following up, and if physicians don't have the information they need to make sure the energy is being applied correctly, then you're not even halfway there, I think. Speak, if you would, just a little more about how this connectivity really elevates these devices to be merely unfair, from devices that provide some therapeutic value to tools that patients can use and really become a better part of their recovery.
Yeah, absolutely. So, when as I mentioned, that our goal really is to kind of innovate in a patient-centric manner. And so when we were thinking about, okay, your neuromodulation therapies work, what can we do? What can we do here to make this better? Um, what we learned is that, there are many, many patients who could benefit from neuromodulation therapies right now who don't actually have access to it because either they don't know enough about it, they just, the biggest barrier is education and awareness, or they just don't have access to a specialist because of geography, because of lifestyle, because of just any other socioeconomic barriers that there might exist. And so we kind of took both of these, gaps that we currently had in the field and thought about how can we use innovation to really bridge that. And so I think the biggest innovation really here is to make sure that as we're applying these therapies, we're doing it in a very secure way. So a lot of the initial effort when we were developing Neurosphere was really on making sure that we were compliant with data privacy and cybersecurity practices. We made sure that we had multiple layers to kind of protect the data that was being transferred through this system, so that the patients and the physician would feel more comfortable and more secure while they were interfacing with this. But we also made sure that this was easy, right? So like our virtual clinic platform that I talked about a little bit, it's initiated by the patient. It's a one click on the patient's side. So they're always in control kind of their therapy. But they also have the ability to access their physician kind of when there is a need, when the problem arises, versus kind of having to wait, 6 weeks, 8 weeks, months, sometimes at a time. The other module that I talked about, our Neurosphere Digital Health app, which includes a module called My Health Journey, which is really focused on education and awareness. We recognize that was another barrier, right? A lot of times, when we think of ourselves as patients, if we're dealing with something, we just never know where to start. We don't know what resources exist, and we never really know how to kind of navigate this journey. And this was an effort really on helping kind of streamline that as well for something that might already be very debilitating and confusing. So with this additional, module in this app that we just released recently, the goal is to kind of allow patients to get access to resources, but also, have access to other patients so that they can hear other patients' stories, testimonials, and then have real-time assistance as well. So a lot of this was really meant to be kind of, holding the patient's hand and making sure that you're serving as a companion with them as they kind of navigate this process, which is incredibly difficult for a lot of them.
So what I'm hearing is that Neurosphere is solving some challenges like access to information, that education you're talking about, the trust that's needed when you're given your information, so the trust for privacy. This is absolutely, I think, integral to the patient journey. Mm-hmm. Do you have any examples of maybe a patient story where it was particularly touched you or you found it to be successful?
Yeah. So I will share a story that's actually a little bit personal to me. So we've been talking about virtual clinic and Neurosphere. When we were actually developing this, I was in R&D and I was the lead scientist for our pilot study that we did, and we actually did the pilot study in Australia. And I got to go down there, beautiful country, wonderful people, and I got to go down there and enroll patients initially for the study. And our very first patient on that study was also the very first patient to get the commercialized version of our Neurosphere Virtual Clinic when we released in Australia. And within hours after he had access to this, he requested, to our team in Australia to have a conversation, to have a virtual conversation, a virtual call with the R&D team in the US, because he wanted to share just how much of an impact this technology had made on his life. And to kind of paint the picture, and pun totally intended, this patient is an artist. He really enjoyed woodworking. He really enjoyed, kind of doing a lot of things with his hands. And neuromodulation, deep brain stimulation as a therapy, was already helping him kind of, manage those symptoms. But he also moved about 4 hours away from his movement disorders neurologist in the middle of the pandemic. And so it was an incredibly difficult, challenge for him to actually access his neurologist exactly when he needed it. His family would have to take some time off to help him kind of make his way to the neurologist's office. And he wanted to really, call us, and he kind of showed us like what, the 4 hours one way, so 8 hours total time that he actually got back. He actually showed us a painting that he had painted that day, basically showing us that, look, you've kind of given me back 8 hours of my time, 8 hours of my life, and I can actually use that time to do the things that really matter to me. I can live my life. I don't have to think about my therapy. I don't have to think about the logistics of, reaching my care provider, because when I need something, I can schedule that, in a very timely fashion, and I can get care without having to kind of just go through hoops, just to get my therapy adjusted. So it's still one of the most touching experiences from working on this technology that I have, and one that I hold very close. I think, maybe you guys are aware, Neurosphere Virtual Clinic won a lot of different accolades, because of how innovative and creative this technology was. But this account, when this patient called us and really wanted to thank us for how much we had impacted his life, I think that meant more to us, just seeing how much of an impact we had on his life.
It's an amazing, an amazing metric to the whatever you gave back to that person's life. It's just to have them to show that piece of art that they created with that time. It's just outstanding. So we're at an exciting point today. We're seeing a lot of fabulous technologies being created today. Looking forward, looking 10 years ahead of now, what do you see happening? Where do you see connected care sort of taking us, and where do we see neuromodulation headed?
Yeah, I actually love the promise of the future here, right? With neurotechnology, I feel like we have learned so much in the last 30 years of this field having matured, right? We've learned so much in the last 30 years, and I just cannot. I feel like when we think about the future, I know you're asking about where does this field go in like 10 years, but I think we're at such an accelerated pace of innovation right now that I think year on year, you're going to see something incredibly different and incredibly powerful. I feel like the field of neurotechnology still has a lot of unknowns as well, even though we've learned so much about it, but it is full of potential. I also think there's a lot to learn from it, right? So a lot of our modern day technology is built on kind of the foundation of brain's unparalleled computing power. From things like transistors to AI, our understanding of nervous system has really kind of inspired these innovations. And now I think it's time to take these innovations and kind of iterate back, right? Using things like AI, using things like digital health, applications, wearables, stuff like that. I think we really have the opportunity to understand more about, how we can continue to improve symptoms and conditions for a lot of these people who are living with neurodegenerative diseases. But also as this technology matures, as we have better ways of imaging people, as we have better computing power, as we have better ways of miniaturizing this technology and bringing it so that it's seamless and real time, right? With things that we've already talked about, things like connected care, which does offer the opportunity for real time assessments, for more holistic assessments as we bring in more concepts of AI into this. What we can really offer patients is seamless, timely, interventions, but also the ability for wider application, right? I know I talked about depression, a little bit earlier, but as when we think about our mission as Abbott, our goal is to be able to serve and help as many people as we can. And when we think about the potential for neurotechnology, I think this kind of innovation that we've been seeing, especially with connected technologies and digital health and AI, I think what it's really going to do is it's really going to help us scale these technologies so that we can really bring it also to indications that have a public health magnitude. So when I think about the future of neurotechnology and neuromodulation specifically within this, to me, I'm really excited about what we've learned so far, but I'm actually more excited about what we're about to learn because of all the tools that we have at our disposal now and how we can really leverage them to just improve the quality of life, to just, give someone else control back of their time and so that they don't really have to think about just the burden of their disease or the burden of their therapy, and they can really live a seamless, normal life.
There's so much, Yagna, to look forward to, and I can see your passion and excitement and certainly share that with you. We kind of joked at the beginning, med tech industry is the best industry in the world. One of us. As a last thought, for those maybe who are looking to get into neuromodulation, why neuromod? Why is that something that we should get more in med tech? Share
Yeah,
more.
I think neuromodulation is amazing. I think it's the coolest thing in the world. And I love it because, kind of like I said, I think everything that we do, every thought that we have, every action that we take, it really is connected to our nervous system. And when things are not working as they should be in the nervous system, it can be incredibly debilitating. I've seen that firsthand with a lot of these patients that we serve, and I've seen the power of this technology. I just think that, the brain and the spinal cord are incredibly complex, but they're incredibly critical to just having a happy, healthy life. And if we can create the technologies that can interface at these levels to keep people happy and healthy, to make sure that they can get happy and healthy, I think that's really the motivation behind why neuromodulation is a field that people should choose.
You're here. Dr. Yagna Pathak, Medical Science Manager of Medical Affairs for Abbott's Neuromodulation business. Thank you so much for joining us on AbbottTalks. It was a thrill to sit down with you.
Thank you so much, Kaylee. Thank you so much, Tom. It was lovely to have this conversation with you. And looking forward to a bright future in neuromodulation.
Thank you so much. Well, that is a wrap. Kayleen Brown, this is our second time together on AbbottTalks. It was a lot of fun. Thank you for agreeing to be on a call with me for 45 minutes.
Well, I mean, it does ask a lot of me, so I understand. No, really, are you kidding me? This is my favorite part of my job, favorite part of this industry is getting to sit in the passion with those who are on the other side of the camera. And actually, after we hung up, after the podcast recording, Yagna and I had a brief exchange about how we're both so passionate about the industry and how we're trying to get more people in our space and bringing right back to the one of us. Like, I really do believe in that. I want the more people we can get as part of this incredible industry, the faster and further innovation is going to go, and it's going to help more patients. And it's the best industry in the world. So I'm riding a high from this conversation. It was such a joy. Thanks for having me.
Oh gosh, no, it's great, it's fun, and of course it wouldn't be possible without our sponsor, Surtech Medical, and we're really happy to have their story told here as well. We cannot do these amazing podcasts without the support of fine folks like Surtech Medical. So thank you to them for being part of this. My hopeful takeaway, I think, is just the connectivity element of what we're talking about, just to see neuromodulation treatments becoming more complete, becoming more, I think, part of a person's lives, becoming more of a useful tool for them, as opposed to just, as we kind of said up top, just a cool outcome that comes from the delivery of energy to the body. I feel like we're really taking a huge step forward for neuromodulation and for medtech.
And the other thing about neuromodulation is it's not just a figurative step forward, but it can be a literal step forward, and that's really exciting. So everything from pain management to Parkinson's, I mean, the opportunities are really limitless. And I think Yagna really walked us through what we can look forward to in the near future, what she's personally looking forward to, and definitely what I'm looking forward to. It was a great conversation all around.
Absolutely. No, it's why we're doing these podcasts, and really thankful to Yagna for sharing her story on the podcast as well. So, Kayleen, this is great. Let's do it again. What do you say?
Done and done. Anytime you'll allow me to share this stage, there's nowhere else I'd rather be. And for our audience,